Welcome. Welcome to this quiet place, a space for gentle stories designed to accompany you into a peaceful night's rest. Tonight, we begin a journey together, a journey into the deep and tranquil story of the cosmos, where ancient myths and modern science whisper the very same truths about wonder and our place within it all. Our story is called Myths and Stars, an exploration of how humanity has always looked to the heavens for answers, for comfort, and for a sense of belonging. Before we begin our descent into the soft darkness of the night sky, I would love to know where you are listening from this evening, what small corner of our world you are in. As we prepare to look up, you can let me know in the comments below. And if you find a moment of peace here, please do support this channel with a like and a subscription. Your kindness makes these journeys possible. Thank you. Now, find a comfortable position. Let your body feel heavy, supported, and still. And let your mind begin to drift upwards into the cool, clear expanse of the night. Our story begins in a place you know intimately, a place you can visit just by closing your eyes and remembering. It begins with the feeling of standing under a vast and silent sky, far from the glow of city lights, where the darkness is not an absence, but a presence. It is a profound and ancient canvas, velvety and deep, and as you gaze into it, something inside of you begins to quiet down. This feeling, this gentle sense of shrinking while also expanding, is not just poetry. It is a deep-seated psychological response, a state of being we call awe. When we are confronted with something so immense, so far beyond our everyday comprehension, our own pressing concerns seem to dissolve into the background. The human nervous system, so often caught in the rhythm of fight or flight, of planning and worrying, has a hidden switch, and the night sky is one of the oldest keys to flip it. The simple act of looking up at the stars gently activates the parasympathetic nervous system, the body's own system for rest and digestion, for calming the heart and slowing the breath. It is a physiological letting go, a surrender to a scale so grand that our own smallness becomes a source of comfort, not fear. We feel connected to something elemental, a silent spectacle that has unfolded for countless generations before us, a constant in a world of endless change. This is the first magic of the stars, the way they reach across impossible distances to bring us a feeling of peace right here, right now, within our own bodies. And as we stand in this tranquil state, our eyes begin their own slow dance with the darkness. The human eye is a marvelous instrument, a sphere of living tissue that evolved to translate the language of light. It holds two different kinds of storytellers within it, two types of photoreceptor cells called rods and cones. Throughout the bright, sunlit day, the cones are our primary guides. They are masters of detail and color, painting our world in vibrant hues of blue and green and red. But as twilight deepens and the world softens into shades of grey, the cones retreat, for they are hungry for light and cannot work in the dimness. It is then that the rods awaken. The rods are the poets of the night. They are far more numerous than the cones and exquisitely sensitive to the faintest whisper of light, capable of detecting a single photon, the smallest possible particle of light. But this incredible sensitivity comes with a trade-off. Rods cannot perceive color. They see the world in monochrome, in subtle gradations of black, white, and silver. This is why the night sky, while sprinkled with stars of fiery red and brilliant blue, appears to our naked eye as a canvas of shimmering silver on black velvet. Our own biology is what lends the cosmos its serene, ethereal palette, turning a universe of vibrant, violent fusion into a silent, peaceful cathedral of light. We are biologically tuned for the quiet wonder of a monochrome masterpiece, seeing not the blazing chaos, but the gentle, steady glow. This perception, this image of countless tiny lights pinned to a dark, overarching dome, gave birth to one of our oldest scientific ideas, the celestial sphere. For thousands of years, it was the most intuitive and elegant way to understand the cosmos. The ancient Greeks, and countless cultures before them, imagined that the Earth was stationary, and all the stars were affixed to the inside of a vast, hollow sphere that rotated around us once a day. It was a beautiful, comforting model that placed humanity at the very center of a predictable, orderly, and divine clockwork. It made sense of the sun's daily journey, the moon's silent passage, and the steady, unchanging patterns of the constellations. It was a universe built to the scale of human perception, a grand ceiling for our terrestrial home. But as our understanding grew, a simple question, a child's question really, began to unravel this tidy picture. The question was first formally pondered by the German astronomer Heinrich Olbers in the 1800s, and it is a paradox of profound simplicity. If the universe is infinite, as many believed, and filled with an infinite number of stars, then no matter which direction you look, your line of sight should eventually end on the surface of a star. In such a universe, the entire night sky should be as bright as the surface of the sun, a blinding, continuous blaze of light. So why, he asked, is the night sky dark? This question, now known as Olbers's paradox, gently tears open the velvet canvas of the night and reveals the staggering, unimaginable truths hiding in the darkness. The darkness itself becomes a clue, a piece of evidence. The simple blackness between the stars tells us that our universe is not infinite in the way we once imagined. It tells us that the universe had a beginning, that it is about 13.8 billion years old, and therefore the light from stars that are farther away than 13.8 billion light-years has not had time to reach us yet. The darkness exists because we are looking into a finite past, and it tells us something even more profound. The universe is expanding. The light from the most distant galaxies is stretched as it travels through this expanding space. Its wavelength shifted so far towards the red end of the spectrum, and then beyond, into infrared and microwaves, that our eyes can no longer see it. The darkness of the night sky, the very thing that allows us to feel that sense of calming awe, is the silent echo of the Big Bang and the tangible evidence of an expanding cosmos. The comforting blackness is not an emptiness to be feared, but a profound storybook, the final, unread pages of a history that is still travelling toward us through the river of time. The sky is not a ceiling, but a window into the deepest, most ancient history imaginable. And so we rest here for a moment, letting this new understanding settle. The quiet darkness is not a void, but a vessel. It holds the light that is still on its journey, the stories that are not yet told. It is the perfect, silent backdrop against which the first and most familiar character of our celestial story can make its entrance. A single, luminous brushstroke of silver, a constant companion on our journey through the deep and whispering dark. Upon that vast, dark canvas, a gentle light begins to bloom. It is a soft, milky glow, a familiar presence that has comforted dreamers and guided travellers since the dawn of human consciousness. It is the moon, our moon, the first and greatest actor to grace the celestial stage. Its arrival in the sky is not a sudden appearance, but a gradual unveiling, a slow drawing of a silver curtain across the void. It seems to possess a serene and quiet intelligence, a personality that has captivated us for millennia. In ancient myths, it was rarely a creator god, full of fire and fury like the sun, but rather a more subtle and thoughtful deity. It was Selene in her silver chariot, pulled by white horses across the Greek sky. It was Tsukuyomi, the serene god of the Japanese night, and Khonsu, the Egyptian traveller who marked the passage of time. The moon was a keeper of secrets, a guardian of the night, and its rhythmic cycle of waxing and waning was humanity's first calendar, a reliable clock ticking off the months and seasons, a predictable rhythm in a world of chaos. This deep, instinctual connection to the moon, this feeling of it as a living, breathing companion, is written into our oldest stories and our very languages, a testament to its profound and steady influence on the human spirit. But behind this gentle, mythic face lies a story of unimaginable violence, a cosmic birth that would have shattered the tranquil night we know today. To ask where the moon came from is to ask a question about the deepest origins of our own world. The leading scientific story of its creation, known as the giant impact hypothesis, is a drama of planetary scale. It proposes that about 4.5 billion years ago, when our own Earth was just a young, molten sphere, it was not alone in its orbit. It had a travelling companion, a protoplanet roughly the size of Mars, which scientists have poetically named Theia, after the Greek Titan who was the mother of the moon goddess, Selene. For millions of years, these two nascent worlds danced a careful gravitational ballet, until their paths inevitably crossed in a cataclysmic collision. Theia struck the young Earth a glancing, devastating blow, an impact so powerful it would have vaporized both bodies into a swirling cloud of superheated rock and gas. For a time, our planet would have been unrecognizable, a glowing, misshapen world surrounded by a spinning ring of debris, a temporary vision of Saturn in our own inner solar system. But gravity, the patient and relentless sculptor of the cosmos, went to work. Over thousands of years, the particles in that glowing ring began to clump together, drawn by their own mutual attraction, coalescing into a single, smaller sphere, a molten daughter born from the collision of two worlds. This new body was the Moon, and it was born 10 times closer to Earth than it is today, a colossal, fiery orb that would have dominated the primordial sky. Its presence in our sky today is a far more serene affair, a testament to the calming passage of deep time. As you look up at it, you will always see the same features, the same familiar patterns that we sometimes call the man in the moon. This is no coincidence. It is the result of a phenomenon called tidal locking, a final, graceful settling from that chaotic, ancient dance. When the moon first formed, it was spinning much more rapidly, but its close proximity to the massive Earth exerted a powerful gravitational pull, creating a bulge in the moon's molten surface, much like how the moon creates tides in our oceans. Earth's gravity tugged relentlessly on this bulge, acting as a brake, slowing the moon's rotation down over millions upon millions of years. Eventually, this gentle but insistent braking action slowed the moon's spin until the time it took to rotate once on its own axis was perfectly synchronized with the time it takes to complete one orbit around the Earth, which is about 27 days. The dance became locked in place, and from that point forward, the moon has only ever presented one hemisphere, one familiar face, toward us. It keeps its far side perpetually hidden, a secret hemisphere that was completely unknown to humanity until the first robotic spacecraft journeyed there in 1959. It is a beautiful and poetic consequence of physics, a final, quiet embrace that left our eternal companion in a state of perfect, peaceful poise. Yet, the moon's influence is anything but passive. That same gravitational force that locked its rotation in place is a powerful and active presence in our world. It is a silent conversation between our two worlds, written in the language of water. The pull of the moon's gravity creates a bulge in the Earth's oceans, and as our planet rotates beneath this bulge, we experience the rhythmic rise and fall of the tides. It is a deep, planetary breath, with the oceans inhaling and exhaling twice each day, a cycle of life driven by our distant, silent partner. For coastal ecosystems, this rhythm is the very heartbeat of existence, shaping the lives of countless creatures. But the moon's gift to Earth is even more profound and far more subtle. Our planet spins on an axis that is tilted by about 23.5 degrees, and it is this tilt that gives us our seasons. Without the moon's steadying gravitational presence, this tilt would wobble chaotically over long periods, swinging between 0 and perhaps as much as 85 degrees. The resulting climate change would be catastrophic, with seasons disappearing or becoming unimaginably extreme. The moon acts as a stabilizing anchor, a gyroscope for our world, ensuring the climatic stability that has allowed complex life to evolve and flourish. It is our silent, unseen guardian, the quiet force that makes our world a gentle and predictable home. And so, as the moon continues its journey across the sky, we watch its face change, not because it is changing at all, but because our perspective is. The beautiful and mysterious phases of the moon, from the slenderest crescent to the full, luminous orb, are simply a result of the changing geometry between the sun, the Earth, and the moon. When the moon is between us and the sunlit side is facing away from us, and we see a new moon, a dark silhouette against the stars. As it continues its orbit, we begin to see a sliver of that sunlit side, a waxing crescent. At the first quarter, we see half of the sunlit side, and then it grows, or waxes, into a gibbous phase, until the Earth is between the Sun and Moon. Then, the entire face that we see is illuminated, and we are gifted with a full moon. From there, the light begins to recede, waning through a gibbous phase, to the last quarter, to a final, slender crescent, before disappearing once more into the darkness, ready to be reborn. It is a simple celestial ballet of light and shadow, a cosmic clock that has measured out the nights of our ancestors and continues to pace the quiet hours of our own rest. The silver chariot has completed its pass, its gentle light a reminder of a violent birth, its steady presence a source of the very stability that allows us to lie here, peacefully, and watch it go. Its cycle is a promise of return, a soft rhythm that lulls the world to sleep, making way for the even greater fire, the hearth of the day that lies just beyond the dark horizon. As the silver chariot of the moon dips below one horizon, a new warmth begins to bleed into the other. The cool, reflected glow of the night gives way to a primordial fire, a deep and resonant source of energy that awakens the world. This is the sun, and its arrival is a daily miracle, a slow and steady resurrection of colour and life. Where the moon was a quiet guardian, a keeper of secrets, the sun in our ancient stories was almost always a king, a powerful and often fiery deity at the very centre of the celestial court. It was Ra, sailing his barge across the Egyptian sky, bringing order to the universe. It was Apollo, driving his golden chariot, a god of light, reason, and prophecy for the Greeks. It was the great hearth of the world, the unwavering fire that held back the chaos of the cold and the dark. This instinct to worship the sun came from a simple, profound truth. All life, all warmth, and all energy flowed from its brilliant face. It was the visible engine of our world, and its daily return was the most sacred promise in the ancient mind, a promise that life would continue, that the world would be born anew. This feeling of the sun as a great cosmic fire is not so far from the scientific truth, but the nature of that fire is something far more strange and powerful than any flame our ancestors could have imagined. The sun is not burning in any conventional sense. It is not a chemical reaction of wood or coal meeting oxygen. It is a star, and its heart is a furnace of creation, a place of such immense pressure and heat that the very atoms of the universe are forged into new forms. In the sun's core, the temperature reaches an almost incomprehensible 15 million degrees Celsius, and the pressure is over 200 billion times that of Earth's atmosphere. In this crucible, the most common element in the universe, hydrogen, is crushed together with such force that 4 of its protons, the hearts of 4 separate hydrogen atoms, overcome their natural repulsion and fuse together to become a single helium nucleus. This process is called stellar nucleosynthesis, a quiet and constant act of alchemy at the heart of our solar system. And in this act, something truly magical occurs. The resulting helium nucleus is just a tiny fraction of a percent less massive than the 4 original hydrogen protons. That minuscule amount of lost mass has not vanished. It has been converted into a colossal outpouring of pure energy, an amount of energy described by Albert Einstein's famous revelation, E equals mc squared. The sun is consuming itself, transmuting 4 million tons of its own matter into light and heat every single second. A quiet, continuous explosion that has been burning steadily for 4.6 billion years and will continue to do so for another 5 billion more. The journey of this energy from the sun's core to its surface is an epic in itself, a voyage that transforms its violent birth into the gentle, life-sustaining light we feel on our skin. A particle of light, a photon, born in the unimaginable fury of the core, does not travel in a straight line. The region surrounding the core, called the radiative zone, is so incredibly dense with plasma that the photon is immediately absorbed and re-emitted by an atom, sent off in a completely random new direction, only to be absorbed and re-emitted again and again and again. This random walk means that a single photon, travelling at the speed of light, can take on average 200,000 years to travel from the core to the next layer. It is a journey of immense time, a slow filtering of raw power. After this long imprisonment, the energy reaches the convective zone, a vast, boiling layer where hot plasma rises to the surface, cools, and sinks again, like a pot of simmering water. The energy is carried along in these great churning currents until it finally reaches the visible surface, the photosphere, and is at last free to stream out into space as sunlight. This incredible journey is what turns the gamma rays of the core into the gentle visible light and warmth of the photosphere. The sun's immense density acts as a cosmic buffer, a great regulator that turns a chaotic furnace into a steady, reliable star. And this steady, filtered light, journeying across 93 million miles of empty space, is what makes our world possible. Earth orbits the sun within a very special region, a sliver of space known as the circumstellar habitable zone, or more poetically, the Goldilocks zone. It is the region around a star where the temperature is just right, not too hot and not too cold for liquid water to exist on a planet's surface. If the Earth were just 5% closer to the sun, its oceans would have boiled away long ago, leaving a scorched and sterile world like Venus. If it were a little farther out, those same oceans would be frozen solid, locking the world in a permanent and lifeless winter. Our planet exists in this delicate, life-sustaining embrace, a beneficiary of a precise and precious cosmic geography. It is in this gentle stream of sunlight that plants learn the trick of photosynthesis, converting light into the energy that fuels nearly all life on Earth. Every meal you have ever eaten, every breath you have ever taken, is a gift of sunlight, a small piece of the sun's ancient fire, captured and passed down through the intricate web of life. But the sun's influence extends far beyond the light it gives. It also breathes. From its outer atmosphere, the corona, a constant stream of charged particles, mostly protons and electrons, flows outward in all directions, a celestial river known as the solar wind. This wind travels at over 1,000,000 miles per hour, a constant, invisible storm that washes over all the planets. Without protection, this stream of radiation would strip away our atmosphere and make life on the surface impossible. But Earth has a guardian, an invisible shield generated by the molten iron in its core, the magnetosphere. This magnetic field deflects the solar wind, channeling it around our planet like a rock in a stream. And where this celestial river grazes our upper atmosphere near the poles, it puts on one of the most beautiful displays in all of nature. The particles of the solar wind collide with atoms of oxygen and nitrogen in our air, exciting them and causing them to glow in ethereal curtains of green, red, and violet light. These are the auroras, the northern and southern lights, a breathtakingly beautiful vision of our planet's invisible shield in action. It is the sun's unseen breath made visible, a silent and luminous dance in the polar skies. The sun, then, is not merely a distant ball of fire, but the true center of our world, a dynamic and complex engine whose every tremor and every breath shapes our existence. It is the anchor of a great and beautiful system, its immense gravity holding a whole family of worlds in a steady, predictable orbit, a retinue of silent companions on its long journey through the Milky Way. Among the infinite, distant stars, there are a few special points of light that belong to this local family, and they move to a different, more intricate rhythm. They are the wanderers. As the sun's light gives way once more to the encroaching twilight, the familiar canvas of the night returns, but our perspective has changed. We now understand the sun as our local star, the gravitational heart of our home in the cosmos. And against the distant, glittering backdrop of truly remote stars, a few bright points of light stand out, not because they are brighter, but because they refuse to stay still. Night after night, week after week, they drift. The ancient stargazers, with their patient and meticulous observations, were the first to notice this. They saw that while the vast majority of stars rose and set in perfect, unchanging formations, a select few moved with a will of their own. They called them planetes, the Greek word for wanderers, and this simple act of observation was the first great sorting of the heavens, the separation of our solar system from the wider universe. These wanderers were given the names of gods, their appearances and movements woven into the fabric of mythology. There was the swift, fleeting messenger, Mercury, visible only for a brief moment near the horizon at dawn or dusk. There was the brilliant, beautiful beacon of Venus, the goddess of love, outshining all other stars in the evening or morning sky. And there was the fiery, red eye of Mars, the god of war, its color a stark and ominous warning in the darkness. For 2,000 years, the greatest minds in the world wrestled with the puzzle of these wandering stars. Their movements were not simple. They would drift in one direction against the background stars for months, and then, mysteriously, they would slow down, stop, and move backward for a while, before resuming their forward journey. This strange backward loop is called apparent retrograde motion, and explaining it was the central challenge of early astronomy. The most enduring and elegant solution came from the brilliant Greek astronomer Ptolemy, who in the 2nd century AD perfected the geocentric model of the universe. In his vision, the Earth was the stationary center of all things. The sun, moon, and planets were believed to move around the Earth in perfect circles. To account for the strange retrograde motion, Ptolemy devised an ingenious system of circles within circles. He imagined that each planet moved in a small circle, called an epicycle, and that the center of this small circle moved along a larger circle around the Earth, called the deferent. By carefully adjusting the sizes and speeds of these circles, he could reproduce the observed movements of the planets with astonishing accuracy. It was a magnificent piece of intellectual architecture, a celestial clockwork that was both mathematically powerful and philosophically comforting, for it kept humanity at the very heart of creation. For 14 centuries, this Earth-centered vision held sway, a universe built around our own unique and privileged position. But the model was complex, a finely tuned machine of interlocking gears that grew ever more complicated as observations became more precise. It took a quiet revolution, a profound shift in perspective, to bring a new and beautiful simplicity to the wanderer's dance. In the 16th century, the Polish astronomer Nicolaus Copernicus proposed a radical new idea. What if, he wondered, the Earth was not the center of the universe? What if the sun was the great hearth of the system, and the Earth was just another one of the wanderers, another planet orbiting that central fire? This heliocentric model was a daring act of cosmic humility, demoting our world from its privileged position. But in doing so, it solved the puzzle of retrograde motion with breathtaking elegance. The strange backward loop was not a real movement of the planets at all. It was an illusion, a trick of perspective. It is the same illusion you experience when you are in a car on the highway and you overtake a slower car in the next lane. For a moment, as you pass it, the slower car appears to move backward against the distant scenery, even though you both know it is moving forward. In the same way, as the Earth, on its faster inner orbit, overtakes a slower outer planet like Mars, Mars appears to move backward against the backdrop of distant stars for a few weeks. The great mystery was not in the heavens, but in our own changing point of view. With this new sun-centered understanding, the personalities of the planets began to shift from mythic gods to physical worlds. The reasons for their appearances were no longer signs of divine temperament, but clues to their composition. Mars, the god of war, owes its fiery red color to the vast deserts of iron oxide dust that cover its surface. It is, quite literally, a world covered in rust. Venus, the goddess of love and beauty, is so dazzlingly bright because it is shrouded in a thick, unbroken layer of clouds made of sulfuric acid. These clouds are incredibly reflective, bouncing more than 70% of the sunlight that strikes them back into space, making Venus the brightest object in our sky after the sun and moon. And the great king of the planets, Jupiter, with its majestic stripes, reveals its complex atmosphere, with different bands and zones made of swirling clouds of ammonia and water ice, moving at different speeds and altitudes. Each wanderer became a unique world, a place with its own geology, chemistry, and weather, waiting to be explored. And the dance itself, this majestic and orderly procession of worlds around the sun, was found to follow a few simple, elegant rules. In the early 17th century, the German astronomer Johannes Kepler, using the most precise observational data of his time, discovered 3 fundamental laws of planetary motion. He realized that the planets did not travel in perfect circles, as had been believed for centuries, but in slightly oval-shaped paths called ellipses, with the sun not quite at the center. He discovered that a planet moves fastest when it is closest to the sun in its orbit and slowest when it is farthest away. And he found a beautiful mathematical relationship between how long it takes a planet to orbit the sun and its average distance from it. There was no need for Ptolemy's complex system of circles upon circles. The solar system was a far simpler, more graceful, and more profound place than anyone had ever imagined. The wanderers were not chaotic, but were following a script, a cosmic choreography written in the universal language of gravity and mathematics. This newfound order in our own solar system, this family of known worlds engaged in a predictable and beautiful dance, only served to deepen the mystery of the silent, unmoving backdrop. The wanderers were now our neighbours, but what of the countless other lights, the fixed stars that seemed to exist in a realm beyond? Humanity, having put its own house in order, now turned its gaze to these distant points of light, and began to do what we have always done. We started to connect the dots, to find patterns in the void. We have brought the wanderers home, understanding their looping dance not as the whim of gods, but as the elegant and predictable consequence of our place in a sun-centered system. Their mystery has been replaced by a beautiful, mechanical order, and now our gaze drifts past them into the truly deep night, to the silent, unmoving backdrop of the fixed stars. Here, there is no discernible motion, no simple orbit to calculate, only an immense and overwhelming spray of luminous dust across the velvet black. Faced with this sublime chaos, the human mind does what it was born to do. It begins, almost unconsciously, to connect the dots. It seeks familiar shapes, it imposes order on the randomness, it tells a story where there was only silence. This is not a choice, but a deep and ancient instinct, a cognitive reflex that is fundamental to our nature as a species. The psychological term for this tendency is pareidolia, the act of perceiving a meaningful pattern in a stimulus that is, in reality, random. It is the reason we see a face in the craters of the moon, or familiar animals in the shapes of passing clouds. It is our brain's own form of poetry, an attempt to find a signal in the noise, a comforting face in the vast and impersonal unknown. And the grandest canvas for this human tendency has always been the night sky. The constellations are the oldest storybook we have, a celestial gallery of our myths, our heroes, and our fears, projected onto the void. We did not discover the shape of a great bear, Ursa Major, hiding among the stars. We placed it there, a memory of a powerful and respected creature on Earth, a way to organize a patch of sky and pass that knowledge down through generations. The proud figure of Orion the Hunter, with his shining belt and sword, is not a physical reality in the cosmos, but a ghost of our own heroic archetypes, a timeless drama of pursuit and conquest written in starlight. Different cultures, looking at the very same random assortment of stars, created entirely different pictures, projecting their own unique mythologies. Where the Greeks saw a hunter, the ancient Egyptians saw the soul of the god Osiris, and in ancient China, the same stars formed part of a great celestial white tiger. The constellations are a mirror, reflecting not the structure of the universe, but the structure of the human imagination. They are a testament to our universal need to make a home for ourselves in the cosmos, to domesticate the terrifying vastness of the night by filling it with the familiar and the meaningful. This instinct for pattern finding is not a frivolous quirk of our minds. It is a core component of our survival. Our brains evolved to be pattern-matching machines, because in the wild, assuming a pattern where there is none is a much safer bet than ignoring one that is actually there. The rustle in the tall grass might just be the wind, but the brain that momentarily interprets it as the pattern of a stalking predator is the one more likely to survive and pass on its genes. We are the descendants of those who were best at connecting the dots, and so we applied this survival tool to the sky. The patterns we created were not just stories, they were vital tools. They were our first compass, allowing sailors to navigate the featureless oceans by fixing their position relative to the North Star. They were our first agricultural calendar, with the seasonal appearance of certain constellations like the rising of the Pleiades, signaling the right time to plant crops or harvest them. The sky became a vast, illuminated manuscript, a repository of knowledge that was reliable, eternal, and accessible to all. The act of creating the constellations was an act of weaving meaning and utility into the fabric of the cosmos, transforming it from a source of dread into a source of guidance and wisdom. But as the tools of science grew more powerful, they began to reveal a deeper and more subtle truth behind these ancient pictures. We have learned to distinguish between an asterism, the informal dot-to-dot picture, like the Big Dipper or Orion's Belt, and a constellation, which is now an officially defined region of the sky, one of 88 sectors that map the entire celestial sphere, like countries on a world map. The Big Dipper is not a constellation itself, but is merely the brightest part of the much larger constellation of Ursa Major. More profoundly, science has revealed the beautiful illusion that gives birth to these patterns in the first place. The stars in a constellation are not a gravitationally bound cluster, not a physical family of stars traveling together through space. They are, with very few exceptions, complete strangers to one another, separated by unimaginable gulfs of space. They appear to form a pattern only because of a trick of perspective, a line of sight alignment from our unique vantage point on Earth. Imagine looking down a long street at night and seeing two streetlights appear to be right next to each other. One might be only a block away, while the other is a mile distant. They have no physical relationship, but from your perspective, they form a pair. The stars are the same. The three brilliant stars of Orion's Belt, for example, look like a perfectly aligned trio. But the leftmost star, Alnitak, is over 1,200 light-years away, while the rightmost star, Mintaka, is substantially closer, at around 900 light-years. They are separated by hundreds of light-years, fellow travelers only in our imagination. And the final, gentle unraveling of our ancient celestial storybook comes with the understanding that the stars are not, in fact, fixed at all. The phrase, fixed stars, is a beautiful illusion born of the brevity of a human lifetime. Every single star in the sky is in constant, rapid motion, hurtling through our galaxy at hundreds of thousands of miles per hour. They are all engaged in their own vast, slow orbits around the center of the Milky Way. Because they are so incredibly far away, their movement is imperceptible to us from one year to the next. But over the immense timescales of deep time, this proper motion adds up. If we could fast forward 100,000 years into the future, the familiar patterns of our constellations would be warped and twisted into completely new, unrecognizable shapes. The iconic shape of the Big Dipper would be stretched and distorted, its handle bent and its bowl flattened. The Hunter Orion would become a broken, meaningless jumble of lights. The very patterns that seemed so eternal, so central to our ancient understanding of the cosmos, are as fleeting as the clouds in the sky. They are a temporary arrangement, a momentary perspective on a dynamic, ever-changing universe. This realization brings our first act of this journey to a gentle close. We have learned that the patterns we see in the sky are a beautiful projection of our own minds. They are a story we tell ourselves, not a story the universe is telling us. And this frees us. It allows us to let go of the imagined lines, connecting the stars, to look past the grand myths and heroic shapes, and to ask a more intimate and more profound question. If the pattern is an illusion, what then is the reality of a single, solitary dot? What is one of those luminous souls of the night, in and of itself? Letting the grand, imagined patterns of the constellations dissolve back into the darkness, our journey now shifts its focus, diving deeper. We choose a single, anonymous point of light from the billions on display, a tiny, shimmering speck, and we begin a new kind of exploration. We are no longer connecting dots to form a picture, but are instead trying to understand the nature of the dot itself. This is the beginning of our second act, a descent from the myths of the human mind into the physical reality of the cosmos. So, what is a star? At its heart, a star is a breathtakingly simple and elegant thing. It is a vast sphere of incandescent gas, a ball of plasma so massive that its own gravity tries to crush it inward into an infinitesimally small point. But this immense gravitational pressure ignites a furious engine in its core, the engine of nuclear fusion. The star spends its long and stable life in a state of perfect equilibrium, a cosmic balancing act between the inward crush of gravity and the outward explosion of thermonuclear energy from its core. Each point of light you see in the night sky is a place where this titanic struggle is being waged. A distant sun, a luminous soul held in a perfect, fiery poise for billions of years. From our humble vantage point, separated from these objects by trillions upon trillions of miles, it seems an impossible task to know anything more about them. They appear as nothing more than dimensionless points of light, even in our most powerful telescopes. And yet, that single, slender thread of starlight, journeying across the void for years, or centuries, or millennia, is a messenger. It is an ancient letter, and in that light is written the star's deepest secrets, waiting for us to learn how to read them. The most immediate secret the light reveals is the star's temperature. The color of a star is a direct clue to how hot its surface is, in much the same way that a blacksmith's forge contains metal that glows from a dull red to a brilliant orange to a searing blue-white as it gets hotter. The coolest stars we can see are the red dwarfs, their surfaces simmering at a relatively placid 3,000 degrees Celsius, glowing like cosmic embers. Hotter stars, like our own sun, are a yellowish-white, with surface temperatures around 5,500 degrees. And the most massive and luminous stars in the universe are the blue giants, ferocious infernos, whose surfaces blaze at temperatures of 30,000 degrees or more. Astronomers have created a classification system for this, sorting stars by their temperature into a sequence of letters: O, B, A, F, G, K, and M. Our Sun is a gentle and stable G-type star, a warm and life-giving yellow in the grand cosmic spectrum of stellar heat. But the light carries a message far more detailed than just its color. If you pass a beam of starlight through a prism, it will spread out into a rainbow, a spectrum of light. But this rainbow is not perfect. It is sliced through by thousands of fine, dark lines, creating a unique and intricate pattern, a kind of celestial barcode. These are called absorption lines, and they are the key to understanding what stars are made of. Every chemical element, from the lightest hydrogen to the heaviest uranium, has a unique atomic structure that causes it to absorb very specific wavelengths, very specific colors, of light. When the light from a star's hot interior shines through its cooler outer atmosphere, the elements in that atmosphere, hydrogen, helium, iron, calcium, each take a tiny, characteristic bite out of the passing rainbow. They leave behind a ghostly fingerprint, a dark line where a specific color is missing. By analyzing this barcode of missing colors, a science known as spectroscopy, astronomers can determine the precise chemical composition of a star's atmosphere from unimaginable distances. This is how we know that the universe is overwhelmingly made of hydrogen and helium, the first elements forged in the Big Bang. It is how we can see the signatures of heavier elements, cooked in the hearts of previous generations of stars. The starlight is not just a beacon, it is a detailed chemical inventory of a distant world. With the star's temperature and composition revealed, one more crucial question remains. How far away is it? For the nearest stars, the answer lies in a beautifully simple geometric trick called stellar parallax. You can experience this principle right now. Hold one finger out at arm's length and close your left eye, lining your finger up with a distant object. Now, without moving your finger, close your right eye and open your left. You will see your finger appear to jump sideways against the distant background. This apparent shift is called parallax. Because you know the distance between your eyes, your brain instinctively uses this shift to judge how far away your finger is. Astronomers perform the exact same measurement on a cosmic scale. They use the Earth's own orbit as a baseline. An astronomer will carefully measure a nearby star's position against the backdrop of much more distant galaxies. 6 months later, when the Earth has travelled to the opposite side of its orbit, 186 million miles away from its starting point, they will measure the star's position again. The nearby star will appear to have shifted its position ever so slightly. By measuring the tiny angle of this shift, and knowing the vast distance between their two observation points, they can use simple trigonometry to calculate the distance to the star with incredible precision. This is how we began to build a true three-dimensional map of our corner of the galaxy. And so, that single point of light is no longer a mystery. It has a story to tell, a story written in the language of light. Its color speaks of its temperature, its spectral lines whisper of its chemical soul, and its subtle dance in our sky reveals its true distance from us. The starlight that began its journey perhaps before any of us were born arrives tonight, carrying with it an intimate portrait of its source. We are not just seeing the past, we are reading it. And this new literacy, this ability to understand the nature of a single star, opens up an even more profound inquiry. If we can read the story of a star as it is now, can we also learn the story of its entire life? Can we uncover the secrets of where these luminous souls come from and where they are destined to go? Having learned to read the intimate story of a single star in its present moment, a new and even deeper curiosity begins to stir. If we can know its temperature and its composition, can we also know its history? Can we trace the arc of its entire life, from its first breath of fire to its final, fading sigh? The answer, remarkably, is yes. We can do this not by watching one star for billions of years, but by looking around the cosmos and seeing countless different stars at every possible stage of their existence, from birth to adolescence to stable adulthood and dramatic old age. The story of a star's life is written all across the night sky, and it begins, paradoxically, not in light, but in the cold and the dark. The space between the stars, which appears to our eyes as a perfect empty void, is in reality a vast reservoir of diffuse gas and fine dust, a tenuous mist known as the interstellar medium. And within this medium are great, billowing clouds, some stretching for hundreds of light years, regions where the gas and dust are denser. These are the nebulae, the great cosmic factories, the stellar nurseries where new suns are born. These nebulae are among the most beautiful objects in the entire universe, and they come in many forms. Some, like the Great Orion Nebula, glow with a vibrant, ethereal pink. These are emission nebulae, where fiercely hot, newborn stars have already ignited within the cloud, and their intense ultraviolet radiation is causing the surrounding hydrogen gas to fluoresce, to glow in the same way the gas in a neon sign does. Others are a haunting, ghostly blue. These are reflection nebulae, where the starlight is not hot enough to ionize the gas, but instead simply scatters off the fine particles of dust, with blue light scattering more efficiently than red, the very same reason our own sky is blue. And perhaps the most mysterious are the dark nebulae, like the famous Horsehead Nebula, which appear as stark, black silhouettes against a rich backdrop of stars. They are not holes in the fabric of space, but are in fact the very coldest and densest of these clouds, so thick with gas and dust that they completely block all light from passing through them. It is in the silent, frigid hearts of these dark clouds, where temperatures can drop to minus 260 degrees Celsius, just a handful of degrees above absolute zero, that the slow and patient work of gravity begins. Within these tranquil, frozen clouds, a gentle gravitational collapse begins. A region that is just infinitesimally denser than its surroundings starts to pull more gas and dust toward it. As its mass grows, its gravitational pull becomes stronger, and it pulls in even more material, in a slow, self-reinforcing cascade that can last for millions of years. This collapsing clump of gas begins to spin, flattening into a disk, and at its center, the pressure and temperature begin to climb. This glowing, embryonic core is called a protostar. It is not yet a true star, as its warmth comes only from the friction of its gravitational collapse, but it is the seed from which a star will grow. The protostar continues to feed on the surrounding cloud, growing more massive and hotter until a critical threshold is reached. When the temperature in its core soars past 10 million degrees, the conditions become right for nuclear fusion to begin. The moment that first hydrogen atom is fused into helium, a vast wave of energy is released, and the protostar awakens. It is in this moment that it is truly born as a star, entering the long and stable phase of its life, known as the main sequence. It has achieved the perfect balance between the inward crush of gravity and the outward push of its own internal fire, an equilibrium it will maintain for billions of years. How a star lives and dies from this point on is determined by one single factor: its mass. For stars of a lower mass, like our own sun, the end of life is a slow and graceful dissolution. After about 10 billion years of steadily fusing hydrogen into helium, the hydrogen fuel in the core will be exhausted. The star's delicate balance will be broken. Gravity will once again take over, crushing the core and causing its temperature to skyrocket. This new heat will push the star's outer layers outward, causing it to swell into a colossal, luminous red giant, a star hundreds of times its original size, large enough to engulf the orbits of Mercury and Venus. Eventually, this bloated star will become unstable, and it will gently puff its outer layers away into space, creating a beautiful, intricate bubble of glowing gas known as a planetary nebula. At the center of this expanding, ghostly shell, the star's hot, dense core remains. This core, an object about the size of the Earth but with the mass of a sun, is called a white dwarf. It no longer has any fuel to burn, and so it will simply cool and fade over trillions of years, a dying ember in the cosmic graveyard. But for stars born with more than 8 times the mass of our sun, the final act is a far more spectacular and violent affair. These massive stars live fast and die young, burning through their fuel in only a few million years. They fuse heavier and heavier elements in their cores, from hydrogen to helium, then to carbon, oxygen, all the way up to iron. But iron is a cosmic dead end. The fusion of iron atoms does not release energy, it consumes it. The moment the star's core becomes iron, its engine instantly shuts down. With the outward pressure from fusion gone in an instant, gravity wins the final battle, and the core collapses catastrophically in less than a second. This collapse triggers a titanic shockwave that blasts the star's outer layers into space in a cataclysmic explosion known as a supernova. For a few weeks, this single exploding star can outshine its entire home galaxy, a brief and glorious blaze of unimaginable power. In its wake, all that is left is either a neutron star, an object so dense that a teaspoon of its material would weigh 1 billion tons, or, if the original star was massive enough, gravity will crush the core completely, forming a black hole. This dramatic end is not just a death, but also a creation. The incredible energy of a supernova forges all the elements in the universe, heavier than iron, the gold in our jewelry, the silver in our coins, the oxygen we breathe. The explosion scatters these newly created elements, along with all the other elements the star created in its lifetime, out into the interstellar medium. The death of one generation of stars enriches the great cosmic factories, providing the raw materials, the heavy elements, needed for the next generation of stars, for the formation of planets, and for the eventual emergence of life itself. The stars are not isolated islands of fire, but a part of a grand, interconnected cycle of birth, death, and renewal. Citizens of even larger structures, vast cosmic cities of light. The great cosmic factories, with their endless cycles of stellar birth and death, are not scattered randomly throughout the void. They are organized, clustered together into structures of breathtaking scale and beauty. They are the neighborhoods, the districts, the boroughs of vast cities of stars, and we live in one of them. On a clear, moonless night, far from the glare of artificial light, you can see a faint, shimmering band of light arcing across the entire sky. A soft, ethereal river that has been a source of wonder and myth for all of human history. The ancient Greeks saw it as a splash of milk from the breast of a goddess, and so they named it the Galaxias Kyklos, the Milky Circle. We now know this gentle glow for what it is. It is the light of our home city. It is the collective, blended light of billions upon billions of distant stars, our own sideways view into the dense, flat plane of our galaxy, the Milky Way. Our galaxy is a majestic, spinning disk of stars, gas, and dust, about 100,000 light-years across. If we could travel far outside it and look back, we would see a structure of incredible grace, a great celestial pinwheel. At its heart lies the central bulge, a tightly packed, sphere-like collection of hundreds of billions of older, yellower stars, circling a supermassive black hole. Spreading out from this core are the beautiful spiral arms, great, sweeping lanes, where the gas is denser and the great cosmic factories are hard at work. These arms are illuminated by the brilliant blue light of hot, young, massive stars, which are born and die within the arms before they have time to drift away. Our sun is not in a position of any special prominence. It is a humble, suburban star, residing quietly about 2/3 of the way out from the galactic center, in a smaller, partial arm called the Orion Spur, taking a leisurely 230 million years to complete one grand orbit. And surrounding this entire disk, like a faint, spherical halo, is a vast, ghostly sphere of ancient stars and globular clusters, all embedded within an even larger, invisible halo of mysterious dark matter. This is our home, our island in the immense ocean of the cosmos. For a long time, we believed it was the only island. Until about a century ago, the prevailing scientific view was that the Milky Way galaxy was the entirety of the universe. The faint, fuzzy patches of light that astronomers saw in their telescopes, which they called spiral nebulae, were thought to be small gas clouds or emerging solar systems, all contained within our own cosmic borders. But in the early 1920s, a great debate raged. Some astronomers argued that these nebulae were in fact distant galaxies in their own right, island universes, as the philosopher Immanuel Kant had once speculated. The question was finally settled by the tireless work of astronomer Edwin Hubble. Using the new 100-inch Hooker telescope on Mount Wilson in California, the most powerful of its day, he was able to resolve individual stars in the largest of these spiral nebulae, the Great Andromeda Nebula. By finding a special type of pulsating star, he could calculate its distance, and he discovered, stunningly, that Andromeda was nearly 1 million light-years away, far, far outside the most generous estimates for the size of the Milky Way. In a single stroke, the known universe expanded 100-fold. Our galaxy was not the universe. It was just one of countless billions of other galaxies, each a vast island of stars, separated by gulfs of intergalactic space so immense that they beggar the imagination. As we began to survey this newly revealed cosmic ocean, we discovered that these island universes come in a rich and beautiful variety of shapes and sizes, each telling a story of its own history. Edwin Hubble created a classification system for them, a sort of galactic taxonomy. There are the majestic spiral galaxies, like our own Milky Way and Andromeda, with their flat, rotating disks, beautiful arms, and active star formation. Then there are the elliptical galaxies, which are far more serene and settled. They are vast, featureless, three-dimensional swarms of much older stars, shaped like a cosmic football or a sphere, with very little gas and dust left to form new stars. They are the quiet, mature cities of the universe. And then there are the irregular galaxies, smaller galaxies that lack any defined shape at all. They are often chaotic and messy, their strange forms the result of gravitational interactions or violent collisions with other galaxies. Looking out into the universe is like looking at a great celestial ecosystem, with galaxies of all ages, shapes, and sizes, each one a testament to its own unique and dramatic evolutionary path. And just as stars are not scattered randomly, but are organized into galaxies, the galaxies themselves are not alone. They too are bound by the invisible hand of gravity. They are grouped together into galaxy clusters, collections of dozens, hundreds, or even thousands of galaxies, all orbiting a common center of mass. Our own Milky Way is a member of a small, humble cluster of about 50 galaxies called the Local Group, dominated by ourselves and the slightly larger Andromeda Galaxy. And these clusters themselves are part of even larger structures. They are strung together like pearls on a string, forming immense filaments and vast, flattened walls of galaxies that span hundreds of millions of light-years, separated by colossal, almost empty regions called voids. This immense, sponge-like structure is known as the cosmic web, the largest pattern in all of nature. Our local group is just one tiny filament in a supercluster of galaxies that astronomers have named Laniakea, a Hawaiian name meaning immeasurable heaven. We have journeyed from a single point of light to a city of billions of stars, and from that city to an entire universe of such cities, all woven together into a single, interconnected, cosmic tapestry. The scale is almost too vast for the human mind to hold, and yet This grand and intricate structure, from the orbit of a single planet to the filament of a supercluster, seems to obey a single, universal law. It is all held together by an invisible force, a silent and patient architect that sculpts the chaos into order. It is the unseen weaver of the cosmic web. We have journeyed outwards, from our small terrestrial home to a city of stars, and from that city to a universe of countless others, all strung together in a delicate, luminous web. We are left with a feeling of awe, contemplating this grand cosmic tapestry, and a quiet question begins to form in the mind. What is the loom upon which this tapestry is woven? What is the invisible thread that holds these colossal structures together, that guides the dance of planets and the slow waltz of galaxies? For centuries, this unseen weaver had a simple name: gravity. It was a force, an invisible tether reaching across the void, and its first great storyteller was Isaac Newton. In a moment of legendary insight, he realized that the mysterious power that caused an apple to fall from a tree to the ground was the very same power that held the moon in its constant, graceful orbit around the Earth. In this single, profound thought, the heavens and the earth were united under one universal law. Gravity was no longer a terrestrial phenomenon, but a cosmic one, an invisible hand that reached across all distances, pulling every object in the universe toward every other object. For over 200 years, this vision of gravity as a universal force reigned supreme, a beautifully simple and incredibly powerful explanation for the majestic clockwork of the heavens. And yet, for all its power, a few quiet mysteries remained. Newton's gravity worked perfectly as a description of what would happen, but it was silent on the question of how. How did the sun, 93 million miles away, instantaneously inform the Earth of its presence? How did this force transmit itself across the perfect vacuum of empty space? It was as if the universe were haunted by a kind of spooky action at a distance, a puzzle that Newton himself acknowledged but could not solve. It took another singular mind, working centuries later, to offer a new story. A story so strange and profound that it would completely reshape our understanding of the universe. In 1915, Albert Einstein published his general theory of relativity, and in its elegant mathematics, he proposed something radical. Gravity, he said, is not a force at all. It is a consequence of the shape of the universe itself. It is the geometry of a four-dimensional reality he called space-time. To begin to grasp this remarkable idea, we can use a simple, gentle analogy. Imagine the fabric of space-time as a vast, flat, flexible rubber sheet, stretched out perfectly taut. Now, imagine placing a heavy object, like a bowling ball, in the center of the sheet. The ball's mass causes the sheet to curve, to warp, creating a deep depression, a gravity well. If you then roll a smaller object, like a marble, nearby, it will not travel in a straight line. It will follow the curve of the sheet, drawn into an orbit around the central bowling ball. The marble is not being pulled by a mysterious force from the ball, it is simply following the straightest possible path through a curved space. This, Einstein said, is what is happening in our solar system. The sun, with its immense mass, creates a deep well in the fabric of space-time. The Earth and the other planets are not being tethered by an invisible rope. They are simply rolling along the gentle, curved contours of the sun's gravity well. An orbit is nothing more than freefall through a curved dimension. This is the new story of the unseen weaver. It is not pulling threads, but is instead the very shape of the loom itself. This strange and beautiful idea made a number of predictions so bizarre they seemed to belong to science fiction. One of the most famous was that if mass can bend the fabric of space, then even light, which has no mass, should have to follow these curves. Light, Einstein predicted, must bend when it passes by a massive object. This phenomenon, called gravitational lensing, was once a purely theoretical curiosity. Today, our powerful telescopes see its effects everywhere we look. When we observe a massive cluster of galaxies, the combined mass of that cluster creates such a profound warp in space-time that it acts like a giant, natural magnifying glass. The light from even more distant galaxies, located directly behind the cluster from our point of view, is bent and distorted as it passes through this gravity well, often appearing as strange, stretched-out arcs of light, or even as multiple, ghostly images of the same galaxy. We are seeing light that is no longer traveling in a straight line, a stunning and beautiful visual confirmation that the very fabric of the universe is flexible and curved. And in the last decade, we have opened an entirely new window onto this dynamic vision of the cosmos. Einstein's theory also predicted that the most violent and cataclysmic events in the universe should create ripples in the fabric of space-time itself, gravitational waves that would spread outward across the cosmos at the speed of light. Imagine dropping two stones into a perfectly still pond. The ripples they create will spread out, interfere with each other, and eventually reach the far shore. In the same way, when two black holes, or two incredibly dense neutron stars, spiral into each other and collide, they create a storm in the fabric of space-time, a gravitational tremor that travels across the universe. For a century, these waves were far too faint to detect. But now, with incredibly sensitive instruments, we can feel the faintest of these ripples as they wash over the Earth, compressing and stretching our reality by a distance smaller than the width of a proton. We have learned to hear the sound of space-time ringing, a new and ghostly sense with which to perceive the universe's most secret and violent events. With this new understanding, the universe is transformed from a static stage into a dynamic, pliable medium. The unseen weaver is not a force acting upon the universe, but is the very substance of the universe itself, a fabric that can bend and warp and ripple. We feel we have finally grasped the fundamental architecture of the cosmos, the ultimate secret of its structure. And yet, just as we arrive at this new and profound sense of completion, we find that the weaver's masterpiece contains a mystery deeper than any we have encountered before, a mystery hidden in the quiet darkness between the stars. We have found the unseen weaver, the elegant and beautiful geometry of space-time that sculpts the cosmos into the grand structures we observe. With this powerful understanding of gravity, we feel a new sense of confidence. We can now look out at the universe, measure the motions of the stars and galaxies, and weigh the cosmos itself, calculating how much matter it must contain to account for the gravitational structures we see. But when we perform this cosmic accounting, a profound and humbling discrepancy emerges. The universe we see, the luminous and beautiful tapestry of stars and galaxies, is not enough. The weaver's threads seem to be attached to something else, something vast and invisible that holds the cosmos together, something that does not shine. The first hint of this grand mystery came from the gentle, spinning motions of our galactic neighbours. In the 1970s, the astronomer Vera Rubin was patiently studying the rotation of spiral galaxies. Based on everything we knew about gravity, she expected to find that the stars on the outer edges of a galaxy would be orbiting much more slowly than the stars near the bright, dense centre, just as distant Neptune orbits the Sun far more slowly than nearby Mercury. But what she found was astonishing. The stars in the outer regions of the galaxies she studied were moving just as fast as the stars in the inner regions, and in some cases, even faster. They were moving at such incredible speeds that the visible mass of the galaxy should not have been nearly enough to hold on to them. The gravitational pull from all the stars and gas we could see was far too weak. These galaxies should have torn themselves apart, their outer stars flinging off into the blackness of intergalactic space like water from a spinning wheel. For them to remain gravitationally bound, there had to be an enormous amount of extra mass, a vast, invisible halo of some unknown substance, enshrouding the entire galaxy and providing the additional gravitational glue needed to hold it all together. This mysterious, unseen substance, which does not emit, reflect, or block any form of light, was given a simple and fitting name: dark matter. It is a ghostly scaffolding upon which the luminous structures of the universe are built, and we can only infer its presence by the quiet, steady pull it exerts on the things we can see. This was not an isolated puzzle. Evidence for this unseen matter began to appear everywhere we looked. When we observe the gravitational lensing around massive galaxy clusters, the way the light from distant objects is bent and distorted, we find that the amount of bending is far, far greater than can be explained by the mass of all the visible galaxies and hot gas in the cluster. To create such a powerful warp in spacetime, the cluster must contain at least 5 times more mass than we can account for with our telescopes. Dark matter, it seems, is not a minor component of the universe, but is the dominant form of matter, the true gravitational anchor of the cosmos. But even as astronomers were grappling with this deep mystery of missing mass, a second, and perhaps even more profound, cosmic puzzle was emerging. In the late 1990s, astronomers embarked on a project to measure the history of the universe's expansion. They knew the universe was expanding, a legacy of the Big Bang, and they assumed that the mutual gravitational pull of all the matter in the cosmos, both visible and dark, must be acting as a brake, gradually slowing this expansion down over the eons. Their goal was to measure the precise rate of this deceleration. 2 independent teams, using distant supernovae as cosmic mile markers, meticulously made their measurements, and both arrived at the same Nobel Prize-winning and utterly world-shattering conclusion. The expansion of the universe is not slowing down. It is speeding up. The galaxies are not just flying away from each other, they are doing so at an ever-accelerating rate. It was as if you had thrown an apple into the air, and, instead of it slowing down and falling back to the ground, it suddenly shot upwards, faster and faster, into the sky. This was a complete violation of everything we thought we knew about gravity. To explain this cosmic acceleration, scientists have been forced to propose the existence of something even more mysterious than dark matter, a strange, repulsive energy that seems to be woven into the very fabric of space itself, a kind of cosmic anti-gravity that is pushing the universe apart. This unknown influence, which seems to dominate the entire universe, has been given an equally enigmatic name: dark energy. When we put these 2 colossal mysteries together, our picture of the universe is irrevocably transformed. We are forced to confront a new and deeply humbling cosmic budget. All the matter and energy we have ever known, all the stars, planets, nebulae, you, me, everything that is made of atoms, all of it, amounts to less than 5% of the total content of the universe. About 27% of the cosmos is the invisible dark matter, the silent scaffolding that holds the galaxies together. And the vast majority, a staggering 68%, is the mysterious dark energy, the force that is driving the galaxies apart. We are not just living in a universe that is mostly empty space. We are living on a tiny, luminous island of familiar matter, adrift in a vast, unknown, and dark ocean. The map of the universe we thought we had so carefully constructed is almost entirely blank, its greatest continents still waiting to be discovered. We find ourselves adrift in a new and mysterious cosmos, a universe composed almost entirely of a dark ocean of unknown matter and energy. This ocean is not static, it is expanding, and the expansion is accelerating, pushing the luminous islands of the galaxies ever farther apart. This simple, staggering fact that the universe is growing becomes a thread that we can follow backward in time. If we can imagine the great cosmic film of existence, we can gently rewind it. As we do, the galaxies that are now rushing apart begin to come back together. The vast voids of space shrink. The entire universe, which now seems so cold and empty, becomes hotter and denser. We rewind further and further, past the formation of the first stars, past the birth of the first atoms, compressing 13.8 billion years of cosmic history into a single, flowing thought. We arrive, finally, at a moment before which time itself has no meaning. We arrive at the beginning. The Big Bang Theory is not a story of a great explosion in an empty space, for there was no space to explode in. It is the story of the emergence of space and time and all the matter and energy in the universe, from a single point of unimaginable density and heat, a state known as a singularity. In the first fraction of a second of its existence, the universe underwent a period of incredible expansion, growing from a size smaller than an atom to a size larger than a galaxy in a fleeting instant. This was a moment of pure, undifferentiated energy. As the universe continued to expand and cool, this energy began to congeal into the fundamental particles that make up our world today. Quarks, electrons, photons. In the first few minutes, a period of furious cosmic alchemy. The universe was hot enough and dense enough to act as a single, universe-sized star. Protons and neutrons, which had formed from the cooling quarks, came together to forge the first atomic nuclei. This process of Big Bang nucleosynthesis created all of the hydrogen and nearly all of the helium that exists in the universe today, along with a tiny trace of lithium. The theory makes a precise prediction about the ratio of these primordial elements. And when we look out at the oldest stars and the most pristine gas clouds in the universe, we find that the abundances match the prediction perfectly. We are reading the chemical signature of the first 3 minutes of time, written across the entire cosmos. Yet, after this initial flurry of creation, the universe entered a long and quiet period, a kind of cosmic dark age. For the next 380,000 years, the universe was a strange and unfamiliar place. It was a hot, dense, and completely opaque fog. The universe was filled with a searing plasma of these newly formed hydrogen and helium nuclei, and a sea of free-roaming electrons. The particles of light, the photons, were trapped in this cosmic soup, unable to travel more than a few inches without colliding with a free electron and being scattered in a random direction. If you could have existed in this early universe, you would have been surrounded on all sides by a blinding, uniform, featureless glow, like being inside the very heart of a star. There were no structures, no stars, no galaxies, only this impenetrable, luminous mist that filled all of space. The universe was full of light, but it was a universe without a view. Then, after 380,000 years of this steady, patient cooling, the universe reached a critical threshold. The temperature dropped to about 3,000 degrees Celsius, cool enough for the frantic motion of the electrons to slow down to the point where they could be captured by the waiting atomic nuclei. In a moment that was both quiet and cosmically significant, stable, electrically neutral, atoms of hydrogen and helium were formed for the very first time. This event is called recombination. And because the photons of light no longer interacted strongly with neutral atoms, the universe, in an instant, became transparent. The fog cleared. For the first time in its history, light was set free, unchained from matter, and was able to travel in straight lines across the ever-expanding void. This first, brilliant flash of liberated light, this first sunrise of the cosmos, has been traveling through the universe ever since, a silent and faithful witness to the birth of transparency. This ancient light is still here today. It fills the entire universe, washing over us from every direction, though we cannot see it with our naked eyes. Over the course of 13.8 billion years of cosmic expansion, this primordial light has been stretched, its wavelength elongated, its energy diluted. The blinding, white-hot light of the young universe has cooled to a faint, frozen whisper, a bath of microwave radiation with a temperature of just 2.7 degrees above absolute zero. This is the cosmic microwave background, the CMB, the faint afterglow of the Big Bang. It is the oldest and most ancient light in the universe, a baby picture of the cosmos at the moment it was just taking its first breath. When we build telescopes that can see in the microwave part of the spectrum, we see this light coming from every corner of the sky, with an almost perfectly uniform temperature. But within this uniformity are tiny, almost imperceptible fluctuations, regions that were 1/100,000th of a degree cooler or warmer than their surroundings. These tiny ripples, these minuscule imperfections in the otherwise smooth fabric of the early universe, are the seeds of everything that exists today. The slightly denser, cooler spots were the gravitational seeds that, over billions of years, would grow into the great clusters of galaxies, the stars, the planets, and eventually, into us. We are left with this profound and beautiful image of an echo. The entire universe is filled with the oldest story it is possible to tell, the faint, residual warmth from its own creation, a constant and gentle hum that fills all of space and time. It is a tangible link to our own ultimate origins, a story written in a language of ancient light, a message that has been traveling toward us since the very dawn of time. And it makes us wonder, how do we receive such messages from the deep past? What are the messengers that carry these stories across the vast ocean of the cosmos to finally arrive here, with us, tonight? The universe is filled with this faint, ancient echo of its own birth, a story whispered in the language of microwaves. This raises a beautiful and practical question. How do we listen to such a whisper? How do we perceive a message that has been traveling for billions of years? The answer lies with the messenger itself, the most fundamental and mysterious entity in all of physics. Light. Our entire relationship with the cosmos, our every discovery and every moment of wonder, has been mediated by these tireless travelers. But the light that our eyes have evolved to see, the familiar rainbow of colors from red to violet, is just a tiny, narrow window onto a much vaster and more spectacular reality. The full range of light is known as the electromagnetic spectrum, and it is as broad and varied as a grand piano keyboard. The visible light we know is like a single octave in the very middle of this keyboard. To one side, at the lower energy end, are the long, gentle wavelengths of infrared, microwaves, and radio waves. To the other side, at the higher energy end, are the short, powerful wavelengths of ultraviolet light, X-rays, and the most energetic of all, gamma rays. Each of these different kinds of light, each of these octaves on the cosmic keyboard, tells a different story. Each one opens a new window onto the universe, revealing processes that are invisible to our limited human senses. When we build telescopes that can see in radio waves, we are no longer looking at the hot surfaces of stars, but are instead mapping the vast, cold clouds of hydrogen gas that drift silently between them, the raw fuel for future star formation. When we look in microwaves, we see the most ancient light of all, the cosmic microwave background, the echo of the Big Bang itself. In infrared, we can peer through the dense, opaque dust clouds of nebulae, seeing past the obscuring veil to witness the warm glow of newborn protostars, still wrapped in their dusty cocoons. In the high-energy realm of X-rays, we see the most violent and extreme environments the universe has to offer. The million-degree gas swirling around neutron stars, and the matter being torn apart as it falls into a black hole. And in gamma rays, we witness the universe at its most cataclysmic, the final, brilliant death cries of exploding stars or colliding cosmic remnants. To truly understand the cosmos, we must learn to see with all these different eyes, to listen to all the notes on the cosmic keyboard. But the most profound property of these messengers is not their varied energy, but their speed. In the vacuum of space, all forms of light travel at the same ultimate, unbreakable speed limit, a velocity of about 300,000 kilometers per second. This speed is incredibly fast, but it is not infinite, and this simple fact has a staggering implication. It takes time for light to travel from a distant object to us. Therefore, when we look out into the cosmos, we are never seeing things as they are right now. We are always, without exception, looking into the past. The light from our own moon takes about 1.3 seconds to reach us, so we see it as it was 1.3 seconds ago. The light from our sun takes just over 8 minutes to make its journey, so if the sun were to suddenly vanish, we would not know about it for 8 minutes. The light from the nearest star to our sun, Proxima Centauri, takes over 4 years to cross the interstellar void. We see it tonight, not as it is, but as it was 4 years in the past. This is the origin of the unit astronomers use to measure the vast distances of space. The light year, the distance that light travels in 1 year. It is a measure of both space and, inextricably, of time. This turns our largest telescopes into powerful time machines. The beautiful Andromeda Galaxy, our closest major galactic neighbor, is about 2.5 million light-years away. The light that our telescopes collect from it tonight began its journey 2.5 million years ago, when our own human ancestors were just beginning to walk the plains of Africa. When we use a telescope like the Hubble Space Telescope or the James Webb Space Telescope to capture an image of a galaxy that is, say, 10 billion light-years away, we are seeing it as it was 10 billion years in the past. We are watching a young, adolescent galaxy, still in the process of forming its first generations of stars, a snapshot of a time when the universe itself was only a fraction of its current age. The finite speed of light allows us to look back and directly witness the history of the cosmos, to see the evolution of galaxies unfolding before our very eyes. And the expanding fabric of space gives us a remarkable tool for organizing this cosmic history. As a distant galaxy rushes away from us, the light waves it emits are stretched out by the expansion of space during their long journey. This stretching shifts the light towards longer, redder wavelengths, a phenomenon known as redshift. The farther away a galaxy is, the faster it is receding from us, and the more its light is redshifted. By measuring the precise redshift of a galaxy, we can determine its distance, and therefore, how far back in time we are looking. It is a cosmic clock, a calendar that allows us to piece together the entire story of the universe, from the faint, ancient glow of the cosmic microwave background, to the formation of the first galaxies, to the rich and mature universe we see around us today. Every single photon, every particle of light that ends its long journey in our eyes or our instruments, is a messenger, a tiny time capsule carrying a story from a distant place and an ancient epoch. The silent, peaceful night sky is not a static portrait, but a deep and layered museum of all that has ever been. Our new eyes on the universe, our ability to see in X-rays and to hear the faint tremor of gravitational waves, have revealed the cosmos at its most extreme. These messengers carry stories from the most violent and energetic corners of reality, places where matter and energy are pushed to their absolute limits. And in this journey to the edge of understanding, we arrive at the most enigmatic and profound objects in all of creation, the final, quiet victors in the long war between pressure and gravity, the black holes. For a long time, these objects have been the stuff of science fiction, imagined as cosmic monsters, ravenous vacuum cleaners tearing through the fabric of space. But the reality is both simpler and more profound. A black hole is not a monster. It is a natural and inevitable endpoint in the life of the most massive stars. When a star more than 20 times the mass of our Sun finally exhausts its nuclear fuel, its own immense gravity overwhelms all other forces, and the core collapses in upon itself without end. It is a moment of ultimate surrender, where matter is crushed down to a point of infinite density, a place where our familiar laws of physics simply cease to have meaning. This central point of infinite density is called the singularity, a place where space and time, as we know them, come to an end. It is a concept that stretches our minds to their breaking point, a mathematical reality that we cannot yet fully describe. But for any object or person journeying near a black hole, the far more significant feature is the boundary that surrounds this central mystery. This is the event horizon. The event horizon is not a physical surface that you could touch. It is not made of any substance at all. It is a threshold in space-time itself, a point of no return. Imagine a river that flows faster and faster as it approaches a colossal waterfall. At some point, the current becomes so powerful that even the strongest swimmer could not escape being carried over the edge. The event horizon is that point for a black hole. It is the distance from the singularity at which the gravitational pull is so immense that the escape velocity becomes greater than the speed of light. And since nothing in the universe can travel faster than light, anything that crosses this boundary, a planet, a star, a particle of light itself, is irrevocably captured, its story forever lost to the outside universe. It is a one-way door in the cosmos. The strangeness of this place is not limited to its powerful gravity, for according to Einstein's theory of general relativity, this extreme warping of space-time has a profound effect on the flow of time itself. Gravity slows down time. This effect is incredibly tiny for us here on Earth, but near the event horizon of a black hole, it becomes extreme. If you could safely hover just outside the event horizon and watch a friend fall inward, you would witness a bizarre spectacle. Your friend's clock would appear to you to be ticking slower and slower as they approach the boundary. Their movements would seem to slow to a crawl. They would appear to become frozen in time at the very edge of the horizon, their light becoming redder and dimmer, stretched out by the intense gravity, until they faded from view completely, never quite seeming to cross the threshold. From their perspective, however, time would be flowing normally. They would cross the event horizon in a finite amount of time, seeing nothing particularly special about the boundary itself as they passed through it, on their way to the singularity at the center. Time, that most constant and familiar aspect of our reality, becomes relative and pliable in these strange wells of silence. These objects are not just rare cosmic oddities. The universe is filled with them. There are likely hundreds of millions of these stellar mass black holes, the collapsed remnants of dead stars, drifting silently through our own Milky Way galaxy alone. But there is another class of black hole altogether, a breed of monster that is far more massive and far more fundamental to the structure of the cosmos. These are the supermassive black holes, behemoths that weigh millions, or even billions, of times the mass of our Sun. And we have discovered, to our astonishment, that one of these giants appears to reside at the heart of nearly every large galaxy we can see, including our very own. At the precise center of the Milky Way, 26,000 light-years from our quiet suburban home, lies an object known as Sagittarius A star. It is a black hole with a mass of about 4 million suns, a sleeping giant around which our entire galaxy revolves. It is not the remnant of a single star, but is thought to have grown over billions of years, by consuming stars and gas, and by merging with other black holes. These supermassive black holes are not just cosmic leftovers, they are cosmic engines, fundamental architects that have helped to shape the evolution of their host galaxies from the very beginning. And so we are left to contemplate these silent, invisible objects, these places where the fabric of the universe is stretched to its breaking point. A black hole is not an emptiness. It is, in fact, the most completely full place in the entire universe, a place where an immense amount of matter has been compressed into a single, inscrutable point. They are the ultimate expression of gravity's power, the quiet, dark endpoints of the cosmic story of matter. They are the final resting place for the most massive of stars, a place of endings, of silence, and of secrets we may never unravel. Yet, in the grand narrative of the cosmos, these great and violent endings are also, in a way we are only just beginning to appreciate, the very source of new and beautiful beginnings. We have journeyed to the most extreme endpoints of the cosmos, to the violent blaze of a supernova and the silent, inexorable pull of a black hole. These are the dramatic final chapters in the lives of stars, moments of dissolution and collapse. It would be easy to see them as mere endings, as cosmic graveyards where matter goes to die. But this is only half the story. For in these fiery deaths, in these moments of cosmic transformation, are the seeds of all creation. We now begin a journey back from the vast and the impersonal, back to the intimate and the familiar, to a truth so profound it borders on the poetic. It is the truth that the very stuff of our bodies, the atoms that make up our bones and our blood and our breath, were forged in the hearts of stars that lived and died long before the earth was ever born. The popular phrase, "we are stardust," is not a metaphor. It is a literal, scientific reality. We are the children of the stars. To understand this deep connection, we must trace the origin story of the chemical elements, the building blocks of everything we know. In the very beginning, as we have learned, the Big Bang created the lightest and simplest elements. The early universe was a vast and simple place, composed almost entirely of hydrogen and helium, with just a trace of lithium. But a universe made only of hydrogen and helium is a universe without planets, without trees, and without people. For life as we know it, we need the complexity of heavier elements, especially carbon, nitrogen, and oxygen. These elements, and all the others that make up our world, were not made in the Big Bang. They were made in the great cosmic factories, the furnaces that burn at the heart of stars. Inside the core of a star like our Sun, for its entire 10 billion year life, the process of nuclear fusion is steadily converting hydrogen into helium. But in stars much more massive than our Sun, the story continues. When the hydrogen runs out, the core contracts and heats up even more, until it becomes hot enough to fuse helium into carbon. The life of a massive star becomes a series of stages, each one forging a new and heavier element in its core. Helium fuses to create carbon, carbon fuses to create oxygen, oxygen creates neon, and so on, climbing the periodic table. In its final days, the core of a massive star is layered like a cosmic onion, with a central core of iron surrounded by shells of silicon, oxygen, carbon, and helium, all wrapped in a vast outer envelope of hydrogen. But the process stops at iron. The fusion of iron atoms does not release energy, it consumes it. Iron is the final ash of normal stellar burning. And so, the question remains, Where did all the elements heavier than iron come from? Where did the gold in our rings, the copper in our wires, or the uranium in our power plants originate? These precious heavy elements were created in the universe's most spectacular and violent events. The explosion of a supernova. In the final, catastrophic moments of a massive star's death, the energy released is so immense, and the flood of particles called neutrons is so great, that the heaviest elements are forged in a rapid-fire sequence of nuclear reactions. The supernova is not just an explosion, it is an act of instantaneous, universe-enriching alchemy. Now, let us follow the journey of a single one of these atoms, a single atom of carbon, which might, at this very moment, be residing in a cell within your own body. Billions of years ago, this atom did not exist. There was only the simple hydrogen and helium of the early universe. But then, inside the intensely hot and dense core of a star, perhaps 10 times the mass of our Sun, 3 helium nuclei were crushed together to form this one, new, stable atom of carbon. For millions of years, that carbon atom was part of a star. Then, that star died. Perhaps it swelled into a red giant and gently puffed its outer layers away into space, or perhaps it detonated in a brilliant supernova, seeding its surroundings with not just carbon, but also the gold and silver created in its death throes. For eons, our carbon atom drifted through the cold, dark emptiness of interstellar space, a tiny component of a vast, swirling cloud of gas and dust, a nebula enriched with the legacy of a dead star. Then, about 4.6 billion years ago, a shockwave from another nearby supernova may have passed through this cloud, causing it to collapse under its own gravity. At the center of this collapsing cloud, a new star began to form, our Sun. And in the flat, spinning disk of leftover material that surrounded this young star, tiny dust grains began to stick together. Our carbon atom found itself part of this process, becoming a component of a larger and larger body, a planetesimal that eventually grew into the third planet from the Sun, a small rocky world we call Earth. For billions of years, that carbon atom was cycled through rocks, through the oceans, and through the atmosphere. Eventually, through the miracle of biology, it was incorporated into a living thing, passed down through the food chain, through countless plants and animals, and finally, it became a part of you. The iron in your blood that carries oxygen through your veins was forged in a supernova. The calcium that gives your bones their strength was created in the heart of a star. The very oxygen you are breathing at this moment is a gift from an ancient, long-dead sun. We are not separate from the cosmos, looking in from the outside. We are the cosmos, made of its substance, living its legacy. The universe is not a distant, cold, and impersonal place. It is our ancestral home, and its story is our story. Every atom within us has undertaken an epic journey across unimaginable vistas of space and time to be here, now, assembled into the remarkable, conscious being that is you. We are stardust that has woken up, and in our quiet contemplation, the universe is, for a moment, becoming aware of itself. We have journeyed through the great cosmic factories, tracing the story of the atoms within us back to their violent and beautiful origins in the hearts of long-dead stars. This is a homecoming of the deepest kind, a realization that we are not merely living on the Earth. We are the Earth. Its substance is our substance. Its story is our story. And with this newfound sense of intimate connection, our grand cosmic journey now circles back, returning its gaze to our own small world, but seeing it with entirely new eyes. No longer is it the firm, unmoving center of all creation, but something far more fragile, far more precious. In 1990, as the Voyager 1 spacecraft was completing its grand tour of the outer planets and preparing to leave our solar system forever, the astronomer Carl Sagan made a special request. He asked NASA to turn the spacecraft's cameras around one last time and take a final picture of its home. From a distance of nearly 6 billion kilometers, Earth appeared as a single, tiny point of light, a mote of dust suspended in a sunbeam. This image, the pale blue dot, is perhaps the most profound and humbling portrait ever taken of our world. That tiny, fragile point of light is the only home we have ever known. It is the vessel for all the stardust that has ever woken up to ponder its own origins. Its seeming insignificance against the vast, dark backdrop of space belies the incredible confluence of fortunate circumstances that make it a haven for life. To create a world like ours, the universe must follow a very specific recipe. The first and most crucial ingredient is liquid water. Our planet orbits the Sun in a narrow, temperate band called the Goldilocks zone, where it is not too hot for the oceans to boil away and not too cold for them to be permanently frozen in ice. This liquid water is the universal solvent, the gentle medium in which the complex molecules of life can mix and meet and begin the slow dance of biology. But water is not enough. Life also needs a steady and reliable source of energy. Our Sun, a stable, long-lived G-type star, provides this, a gentle and predictable warmth that has shone down for over 4.5 billion years, allowing life the immense time it needed to evolve from single cells into the rich tapestry we see today. And of course, life needs the right building blocks. Thanks to the generations of stars that lived and died before our solar system was born, our world was seeded with a rich abundance of heavy elements. There was the carbon needed for the backbone of all organic molecules, the nitrogen for our DNA, the oxygen for our breath, and the iron for our blood. And finally, to protect this budding biosphere, our world came equipped with its own invisible shield. The molten iron core of our planet generates a powerful magnetic field, the magnetosphere, which deflects the constant stream of harmful radiation from the solar wind and cosmic rays, protecting our atmosphere from being stripped away and safeguarding the delicate chemistry of life on the surface. It is this rare and perfect combination of factors, the right location, the right star, the right ingredients, and the right protection that has allowed this pale blue dot to become a vibrant, living world. For all of human history, we had no way of knowing if this miracle was unique. We looked up at the countless stars in the night sky and could only wonder if any of them had their own families of planets, their own potential havens for life. But in the last 3 decades, that has all changed. We have entered a new age of discovery, and we now know for certain that planets orbiting other stars, known as exoplanets, are not a rarity, but are incredibly common. We have found thousands of them, using ingenious methods that rely on the subtlest of cosmic clues. One of the most successful is the transit method. Telescopes like the Kepler Space Telescope stared at a single patch of sky for years, simultaneously monitoring the brightness of over 150,000 stars, looking for the tiny, periodic dimming of a star's light that occurs when a planet passes in front of it from our point of view. It is like detecting the presence of a tiny gnat flying in front of a brilliant searchlight from miles away. Another method, the radial velocity method, looks for the slight gravitational wobble a planet induces in its parent star, a tiny shift in the star's light towards the blue and red ends of the spectrum as it moves towards and away from us. These remarkable techniques have revealed a universe teeming with worlds. We have found gas giants larger than Jupiter orbiting their stars in a matter of days. We have found rocky super-Earths and planets orbiting 2 suns at once. We have even found planets that may be water worlds, covered entirely in deep, global oceans. And among this incredible diversity, we have found dozens of planets that are roughly the size of Earth and that orbit within the habitable zones of their stars. The great question, the one we are not yet able to answer, is whether any of these worlds have made the final, miraculous leap from being merely habitable to being truly inhabited. The universe, it seems, is full of stages, but we do not yet know if our play is the only one being performed. And this brings us to a quiet and profound puzzle, known as the Fermi paradox. The universe is ancient and vast, and the building blocks for life are everywhere. If the emergence of life is a common occurrence, then our galaxy should be filled with civilizations, many of which would be millions of years older and more advanced than our own. So, the physicist Enrico Fermi once famously asked, "Where is everybody?" The great silence of the cosmos, the lack of any discernible signal from another intelligence, is a deep and humbling mystery. It does not necessarily mean we are alone, but it underscores the profound preciousness of what we have here. We look back at that pale blue dot, that tiny, fragile stage, and we see it now not just as our home, but as a place of immense and perhaps unique value. It is a lonely outpost of life in the cosmic dark, a place where Stardust has been given the rare and beautiful opportunity to think, to feel, and to wonder. The long and silent history of this one small world is a story of almost unimaginable depth, a story that can only be appreciated when we learn to think on the timescale of the stars. To truly appreciate the story of our pale blue dot, to understand the sheer, breathtaking improbability of our own existence, we must learn to let go of our human scale of time. We must gently dissolve our familiar notions of minutes and days and centuries, and allow our minds to drift into a much deeper and more ancient river. We must learn to contemplate the universe on its own terms, in the vast, almost unimaginable timescale that geologists and astronomers call deep time. Our minds are not naturally built for this. We live our lives in fleeting moments. Our memories stretch back decades, and our written histories cover only a few brief millennia. The number 1 billion is something we can write down, but it is a quantity our intuition cannot truly grasp. The story of the cosmos, however, is written in these very numbers, and to read it, we need a new kind of calendar, a new way to map the immense and silent passage of the eons. The most beautiful and effective tool for this is the cosmic calendar, an analogy that compresses the entire 13.8 billion year history of the universe into a single, familiar year. In this calendar, the Big Bang, the moment of creation, occurs at the very first instant of January 1st. For months, the universe is a dark and simple place, as the first stars and galaxies slowly begin to form. Our own Milky Way galaxy does not take shape until sometime in May. The months of June, July, and August pass by in this silent, sprawling galaxy. It is not until early September, on the 9th day of the month, that a small, insignificant cloud of gas and dust collapses to form our Sun and its family of planets, including the Earth. Almost as soon as the Earth is formed, its surface cools, and the first simple, single-celled life appears in its oceans, around the 21st of September. For the rest of September, for all of October, and for most of November, life remains simple, microscopic, a quiet and patient unfolding in the deep. It is only in mid-December that life begins to truly diversify. The first fish and vertebrates appear on December 18th. The first forests cover the land on December 20th. The great age of the dinosaurs begins on Christmas Eve, December 24th, and they roam the Earth for 5 full days, a reign of over 160 million years. Then, on the evening of December 30th, a great asteroid strikes the Earth, and the dinosaurs vanish forever. In the grand cosmic year, this is just yesterday. And what of us? What of humanity? The first of our direct ancestors do not appear until the evening of December 31st. All of recorded human history, every king and queen, every empire and revolution, every book ever written, every piece of music ever composed, every act of love and war, all of it takes place in the last 14 seconds of the year. The life of the person who discovered the laws of gravity and the life of the person who first painted a masterpiece all flicker by in a fraction of the final tick of the clock before midnight. This perspective is not meant to diminish us, but to place us. It is meant to instill a profound sense of humility and an even more profound sense of wonder. We are the beneficiaries of an immense and unbroken chain of events, a story of cosmic and biological evolution so long and so patient that it defies our everyday comprehension. We are living in a fleeting, shimmering moment at the very end of an impossibly long year, and the simple fact that we are here at all is the greatest of miracles. This grand, external flow of time, this river of the cosmos, also has a direction. We experience time as an arrow, always flying from the known country of the past into the unknown territory of the future. This arrow of time is deeply connected to a fundamental law of physics, the second law of thermodynamics, which states that in any closed system, the amount of disorder, or entropy, always tends to increase. A perfect sandcastle will eventually crumble into a disordered pile of sand. A hot cup of coffee will cool as its heat dissipates into the surrounding room. The universe as a whole is moving from a more ordered state in the past to a more disordered state in the future. It is this inexorable increase in entropy that gives time its forward momentum. We remember the past because it was a more ordered state, but we cannot remember the future because it has not yet happened. And yet, within this vast, indifferent, and objective flow of cosmic time, we each experience our own personal, subjective river of time. Our internal perception of time is elastic and strange, governed by our attention and our emotions. A moment of intense joy or sudden fear can feel as if it stretches on forever, as our brain processes an immense amount of information. A long period of routine or boredom, on the other hand, can seem to contract in our memory, leaving almost no trace at all. Our minds are constantly speeding up and slowing down our experience of the world, a strange and personal counterpoint to the steady, majestic ticking of the cosmic clock. We are creatures that live both in the grand, objective river of cosmic time and in the small, personal stream of our own consciousness. We rest here, for a moment, in this peaceful and profound awareness. We are a brief and beautiful flicker of consciousness in an ancient and immense universe. The atoms that compose us are as old as the stars, but our time to be aware of them is fleetingly short. And this realization does not make our lives feel small. It makes this present moment, this simple act of quiet breathing and gentle listening, feel infinitely vast and immeasurably precious. We are, for this briefest of moments, the universe's opportunity to know itself. We are left in a state of quiet contemplation, resting in the awareness of our own fleeting moment within the immense river of cosmic time. And in this awareness, we arrive at the most profound and intimate mystery of all. We have spoken of the universe, of its stars and galaxies, of its laws and its history, but we have not yet spoken of the one thing that allows any of this to be known at all. We have not spoken of the mind that is doing the contemplating. How is it that a universe of mindless, non-living stardust, of hydrogen and helium gas, governed by the simple laws of physics, can give rise to a being that is aware? How can a collection of atoms, forged in the heart of a star, assemble itself into a mind that can look back out at those very stars and feel a sense of wonder, a sense of awe, a sense of connection? This question, the question of consciousness, is the quiet, luminous heart of our entire cosmic story. The answer, if we can call it an answer, seems to lie in a beautiful and subtle concept known as emergent properties. An emergent property is something that arises from the collective interactions of many smaller, simpler parts, but is not present in any of the individual parts themselves. A single molecule of water, H2O, is not wet. It does not possess the quality of wetness. But when you gather trillions upon trillions of these molecules together, the property of wetness, of liquidity, emerges from their collective dance, from their constant bonding and breaking. In the very same way, a single neuron in your brain, a single living cell, is not conscious. It is a tiny, intricate, biological machine that can fire an electrical signal, but it does not have thoughts, or feelings, or awareness. Yet, from the fantastically complex and interconnected network of nearly 100 billion of these neurons, all chattering and signaling to each other in a symphony of electrochemical energy, the property of consciousness somehow emerges. Your thoughts, your memories, your feeling of being here, right now, listening to these words, are the wetness of your brain, a holistic property of the entire system that cannot be found in any of its individual parts. And what are these parts made of? The brain is not some ethereal, magical substance. It is made of the most common elements in the universe: carbon, oxygen, nitrogen, and hydrogen, all obeying the very same laws of physics and chemistry that govern a distant nebula or the core of a star. Through the patient, 4 billion-year process of biological evolution on this planet, these humble atoms have been arranged into the most complex structure we know of in the entire universe. Neuroscientists are now beginning to map the intricate patterns of this structure, to find what they call the neural correlates of consciousness, the specific patterns of brain activity that correspond to a particular subjective experience. They are searching for the precise, rhythmic dance of stardust that gives rise to the feeling of joy, the memory of a childhood home, or the thought of a distant galaxy. The mind is not something separate from the physical world. It is the physical world, arranged in a particular and exquisitely complex way, waking up to itself. This strange fact that the universe has given rise to observers who can comprehend it has led to a deep philosophical reflection known as the anthropic principle. In its weak form, this principle is a simple and logical observation. Of course, we find ourselves living in a universe whose fundamental laws and constants are precisely tuned to allow for the existence of life. Because if they were any different, we would not be here to observe them. It is a kind of selection bias. If the force of gravity were just a tiny bit stronger, the universe would have collapsed back on itself long ago. If it were a tiny bit weaker, galaxies and stars would never have formed. The fact that we are here to measure these constants means they must have the values that they do. It is a gentle reminder that our existence is balanced on a knife's edge, a product of a remarkable and perhaps improbable fine-tuning of the cosmic recipe. But there is a more poetic and profound way to feel this connection. The mind is not an outsider, looking in at the universe through a window. The mind is an expression of the universe. Imagine a stream of ancient starlight, a photon that has travelled for 1,000,000 years from a distant star. That photon completes its long journey by entering the pupil of your eye and striking your retina. In that instant, its energy is converted into a tiny electrical signal that travels along your optic nerve and into your brain. There, it triggers a cascade of neural activity, a pattern of firing neurons that your consciousness interprets as a single, shimmering point of light in a dark sky, accompanied, perhaps, by a feeling of peace and wonder. In that seamless, silent transaction, the universe without has become the universe within. The physical reality of a distant star has been transformed into the subjective reality of a conscious experience. The observer and the observed are not two separate things. They are two ends of a single process, two parts of one great, unfolding story of the cosmos, becoming aware of itself. And this mind, this miraculous instrument of awareness born from ancient stars, finds its deepest peace and its most profound sense of meaning, not in randomness or in chaos, but in order. Our consciousness is a pattern-seeking machine, and it resonates most deeply with the great underlying patterns of the universe itself, the silent and beautiful harmonies that are written into the very fabric of existence, from the smallest of things to the very largest. The conscious mind, this awakened corner of the cosmos, has a deep and innate affinity for harmony and order. We are drawn to it, we find comfort in it, and we call it beauty. And perhaps the most fundamental and universal form of this beautiful order is the principle of symmetry. We see it all around us in the natural world, a silent, repeating motif that our minds are exquisitely tuned to perceive and appreciate. Think of the perfect, six-fold symmetry of a single snowflake, each intricate arm a perfect mirror of the others, a frozen jewel of crystalline order. Think of the bilateral symmetry of a butterfly's wings, painted with an identical, intricate pattern on each side, or the gentle, pleasing symmetry of a human face. Think of the radial symmetry of a flower, its petals unfurling from a central point in a pattern of perfect, repeating grace. Our connection to these forms is deep and instinctual. We do not need to be taught that they are beautiful. We feel it as a kind of resonance, a quiet sense of rightness and harmony in the world. For a long time, this was seen as a purely aesthetic principle, a matter of beauty and art. But in the last century, physicists have made a discovery that is one of the most profound in all of science. Symmetry is not just about beauty, it is the very source of the fundamental laws of nature. A physicist named Emmy Noether proved mathematically that for every continuous symmetry in the laws of physics, there must be a corresponding conservation law, a quantity that must always remain constant. This powerful idea, known as Noether's theorem, is the secret engine running beneath the surface of reality. The simple and beautiful fact that the laws of physics are the same everywhere in the universe, that an experiment performed here on Earth will yield the same result as one performed in the Andromeda galaxy. This spatial symmetry is the reason that momentum is always conserved. The fact that the laws of physics do not change over time, that the force of gravity is the same today as it was 1 billion years ago. This temporal symmetry is the reason that energy is always conserved. The deepest rules that govern the cosmos are not arbitrary. They are the direct and necessary consequences of its most fundamental symmetries. The harmony we perceive as beauty is a direct reflection of the laws that hold everything together. And when we turn our gaze outwards, we see these same symmetries written on the grandest of scales. We see them in the majestic, sweeping arms of a spiral galaxy, a beautiful example of a logarithmic spiral symmetry. The same kind of symmetry we see in the shell of a nautilus or the unfurling of a fern. We see it in the almost perfect spherical shape of stars and planets, the most energy-efficient and symmetrical shape for a massive object held together by its own gravity. And when we zoom out to the very largest scales of all, we find that the universe itself appears to be deeply symmetrical. On average, the cosmic web looks the same in every direction we look, a property called isotropy, and it has the same average density and structure in every location, a property called homogeneity. The entire cosmos, in its grandest aspect, is built upon a foundation of profound and simple symmetry. Yet, as perfect as these symmetries are, the universe also reveals the creative power of breaking them. Sometimes, for complexity and structure to arise, a state of perfect symmetry must be shattered. Imagine a perfect, featureless pond of water in winter. Its surface is completely symmetrical. Every point is the same as every other. But as the temperature drops, the water begins to freeze. The first ice crystal forms, and it chooses a particular direction to grow in, instantly breaking the perfect symmetry of the pond and creating a new, more complex and more intricate structure. Many physicists believe that a similar process of broken symmetry occurred in the very first moments after the Big Bang. In the extreme heat and energy of the early universe, it is thought that the fundamental forces of nature, gravity, electromagnetism, and the nuclear forces were all unified into a single, perfectly symmetrical superforce. As the universe expanded and cooled, this primordial symmetry broke, one by one, allowing the individual forces to freeze out and take on their unique identities. It may be that the very existence of matter itself is the result of a tiny flaw. A slight break in a once perfect symmetry between matter and antimatter, a crack in the primordial mirror that allowed our universe to come into being. And so we are left with this gentle and profound realization. The principle of symmetry is a golden thread that weaves its way through all of creation. It connects the quiet, aesthetic pleasure we feel when we gaze at a simple flower to the immutable conservation laws that govern the dance of galaxies. It is the language of both physics and art, of truth and of beauty. It is a deep and resonant harmony between the universe without and the universe within, a harmony that our conscious minds, themselves a symmetrical and beautiful product of the cosmos, seem to have been born to recognize and to cherish. Our journey has led us to this quiet and contemplative space, where we can feel the deep harmonies of the universe, the silent and beautiful symmetries that connect the structure of a snowflake to the laws that govern a galaxy. We have found that the conscious mind, itself, a product of the cosmos, is exquisitely tuned to perceive this order, to find in it a sense of peace and a feeling of beauty. But this leads us to a final, gentle reflection on the nature of understanding itself. How do we build these stories that give us meaning? Throughout our long journey tonight, we have been weaving together two great human narratives, two different ways of reading the story written in starlight, the ancient way of myth and the modern way of science. And from this peaceful vantage point, we can see them not as adversaries in a battle for truth, but as two different and beautiful expressions of the same deep human need to find our place in a vast and mysterious cosmos. The myths of our ancestors were humanity's first great attempt to make sense of the world. They were profound and powerful stories that answered the great why questions of existence. Why does the sun cross the sky each day? It is the god Apollo, driving his fiery chariot. Why do we have seasons of warmth and cold? It is the story of Persephone, her annual journey to the underworld, bringing winter's grief to the world, and her return, bringing the joy of spring. These stories gave the universe a human face, a personality. They populated the silent, impersonal void with intention, with purpose, with love, and with jealousy. They were not concerned with the precise mechanics of the world, but with our emotional and spiritual relationship to it. Myths were the glue that held societies together, the vessels that carried cultural wisdom through the generations, and the maps that guided the inner life of the soul. They transformed a universe that might have seemed chaotic and terrifying into a home that was alive with meaning. Science, on the other hand, is a different kind of story, born of a different kind of questioning. It is a story that is less concerned with the why and more obsessed with the how. How does the Earth orbit the Sun? It is a consequence of the curvature of space-time, created by the Sun's immense mass. How are the elements that make up our world created? They are forged in the nuclear furnaces at the hearts of stars. The scientific method, at its core, is a process of deep and structured humility. It is a way of asking questions of the universe and then listening, with great care and patience, to the answers. It begins with an observation, leads to a creative guess, a hypothesis, and then, most importantly, it insists that this guess be tested against the evidence of the real world. A scientific story is not held to be true because it is beautiful, or comforting, or ancient. It is held to be true only as long as it continues to agree with the data, and it must always be ready to be revised, or even completely abandoned, in the face of new evidence that contradicts it. This commitment to self-correction, to being willing to be proven wrong, is the very heart of the scientific endeavor. The philosopher of science, Karl Popper, called this principle falsifiability. He argued that for a theory to be scientific, it must make predictions that are testable, predictions that could, in principle, be shown to be false. It is this quality that gives science its immense power to build reliable knowledge about the world. It finds its strength not in a dogmatic claim to final, absolute truth, but in its own built-in, systematic process for identifying and correcting its own mistakes over time. And this process does not always move in a straight line. As the historian Thomas Kuhn observed, science often proceeds through long periods of stability, followed by sudden, revolutionary paradigm shifts. These are moments when our entire worldview is overturned, when the old story is found to be no longer adequate, and a new, more powerful story takes its place, as when the comfortable, earth-centered cosmos of Ptolemy gave way to the humbling, sun-centered system of Copernicus. Our current understanding of the universe, with all its dark matter and dark energy, is almost certainly just one chapter in a much longer, still unfolding book. And in the end, we find that science, for all its rigor and mathematics, is still a deeply human and creative act of storytelling. To make the incomprehensible comprehensible, scientists rely on the very same tools as the myth-makers. They use models, metaphors, and analogies. We imagine space-time as a flexible rubber sheet, or the history of the universe as a single calendar year. These are not the reality itself, but stories we tell ourselves to help our minds grasp a reality that is far stranger than our everyday intuition can handle. The story of science and the stories of myth both spring from the same source. The innate human desire to look up at the great, silent mystery of the night sky and to weave a narrative of connection, to tell a story that makes sense of our place within it all. The scientific story, written in the ancient light of the stars, is a book with no final chapter, and its beauty lies in the fact that it is never finished. It does not rob the universe of its mystery, but deepens it at every turn, inviting us all to be a part of its endless, unfolding wonder. We find ourselves at the end of our long journey tonight, resting in the quiet understanding that the story of the cosmos is a great, unfinished book, and we are a living, breathing part of its narrative. As we prepare for a deep and final rest, let us gently gather all the threads of our exploration and weave them into a single, peaceful thought, a final synthesis of our place in this vast and beautiful universe. We have traveled from the ancient myths that gave the stars their names to the modern science that reads their chemical souls. We have journeyed from our own solar system to the edge of the visible universe, and from the beginning of time to this very moment. And through it all, one profound and unifying truth has echoed again and again: the deep and unbreakable connection between the life within us and the life of the cosmos. The iron that gives our blood its strength and its color was forged in the heart of a supernova. The calcium that gives our bones their structure was created in a star that lived and died billions of years ago. We are not just living on the Earth, we are the Earth, and the Earth, in turn, is a child of the stars. This is the ultimate homecoming, the quiet and certain knowledge that our most intimate substance is the substance of the universe itself. This connection reveals a cosmos that is not a collection of isolated, separate objects, but a single, vast, and deeply interconnected whole. The universe is a great, intricate web of relationships. The gravity of a distant galaxy tugs, however faintly, on our own. The light from an ancient exploding star travels for 1 billion years to finally deliver its message to our telescopes. The fundamental laws of physics that dictate the perfect, six-fold symmetry of a snowflake are the very same laws that orchestrate the majestic, spiral dance of a galaxy. There is no true separation. We are a part of this web, a temporary and intricate pattern woven from the same threads as everything else, a conscious eddy in the great cosmic river. And as you lie here now, feeling the gentle weight of your body, you can feel this profound connection in the most simple, intimate, and rhythmic way possible, through the gentle act of your own breathing. Allow your awareness now to rest on your breath. Feel the slow, cool intake of air and the warm, soft release of the exhale. There is no need to change it, no need to control it, just the simple, peaceful observation of this ancient, life-sustaining rhythm. This breath, this simple, quiet act, is a direct conversation with the cosmos. The oxygen that is entering your lungs in this very moment, the element that is fueling every cell in your body, was created in the core of a star at least 5 billion years ago. That star, in its death, cast this oxygen out into the interstellar medium, where it drifted for eons as part of a great cloud of gas and dust. That cloud eventually collapsed to form our sun, our planet, and our atmosphere. And tonight, that very same oxygen, a true piece of stardust, has completed its long and epic journey by becoming a part of you. Your breath is the whisper of a dying star, a silent and constant reminder of your deep, elemental origins. And just as you have your own quiet rhythm, the universe has its own grand, slow respirations. There is the slow and steady breath of space-time itself, expanding ever outwards, carrying the galaxies on its silent current. There is the great, cyclical breath of the cosmos, as stars are born from clouds of gas and dust, and then, in their dying, return that material to the void, enriched and ready for a new generation. There is the frantic, rhythmic pulse of a neutron star, a cosmic lighthouse spinning hundreds of times a second. Your own small, gentle rhythm of breathing is a perfect, personal echo of these great cosmic cycles. You are breathing in unison with the universe. And in this awareness, we arrive at our final destination, a state of peaceful, wondrous awe. Awe is the feeling that bridges the scientific and the spiritual. It is the emotion we feel when we are confronted with something so vast, so beautiful, and so profound that our own sense of self dissolves into a feeling of connection with something much larger. It is the humility of knowing that we do not have all the answers, and the quiet joy of being able to ask the questions. It is in this state of gentle, restful awe that we will now let our story come to a close. Thank you for joining me on this journey through myths and stars. I hope it has brought you a measure of peace and a sense of wonder. If these gentle stories for sleep are helpful to you, please do consider offering your support by liking this video, subscribing to the channel, and perhaps leaving a comment below to share your thoughts. Your kindness is what makes these journeys possible, and I am deeply grateful for it. But for now, all that is left to do is to let go. Let go of all these thoughts, let go of the day, and allow yourself to drift into the deep and quiet peace that you so richly deserve. Until we meet again, may your rest be deep, and may your dreams be filled with the silent, gentle light of the stars. Sleep well.